Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Rafif Azzam Dzakwan, and on this session I want to share with you guys about one of the topics for our S level physics, which is superpose, diffraction, and interference. So these are the definition. You can read by yourself by pause the video, and we'll go straight to the next one. Superposition. So basically, what is superposition? Superposition is when two or more waves meet at the same point, the resulting displacement is simply the sum of the individual displacement of each wave. So from this example A and example B, you can see that there is two waves meet at the same point, like crest meeting with crest and trough meeting with trough, crest with crest. Okay, this one, the displacement is A, or the amplitude is A. So they will add to each other moment by moment, resulting to make the resultant wave as 2A for the displacement. So they just simply add each other. This is called as constructive interference. And this one is another example. If they meet and not in line like this, and they do overlapping each other by more than half of their wavelength, resulting in crest meeting with trough, or A meeting with negative A, they will resulting in 0A in their resultant wave. So this explains why the wave is gone. On the second example, it's called as destructive interference. Okay, so that is the explanation about superposition. Next one we have is diffraction. So diffraction happens when, diffraction is the bending or spreading of waves as they pass through a gap or around an obstacle. So the amount of spreading itself, it depends on the relationship between the size of the gap and the wavelength, size of the gap and the wavelength of the wave. So the wider the gap, resulting in the lower the diffraction effect. And the narrower the gaps, they will resulting in the higher diffraction effect. This is about diffraction. So let's move to the next one, which is the interference. This is the combination of the two topics that we've been discussed before. Okay, so interference occurs when two or more waves from coherent source. Coherent source means that they have the same frequency and constant phase difference. When this happens, we'll get a pattern. We'll get a pattern of alternating bright and dark fringe. Bright and dark fringe. We'll get the expression of if the fringe is bright, it means that the path difference will be n wavelength, and if it's dark, the phase difference will be n plus half wavelength. It means that bright moves the difference to the dark fringe will be half of the wavelength, and if bright move to bright fringe, it will be one wavelength. So this is for the sample style question that we will use for this session. So the first one, microphone cathode oscilloscope or CRO are used to analyze a sound wave of frequency 5,000 Hertz. So these are the CRO we can see on the screen. Frequency is 5,000 Hertz, and we got to find and determine time as setting. So frequency and time is related by the equation of frequency 1 over period, and we want to find the period is equal to 1 for f. Is swap the f and t. Then later on we'll find 1 over 5,000. And we'll see the period is only for one cycle, for one length, one wavelength. This is, if you calculate this one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. This is equal to 4 centimeter. You can see that 1 centimeter is equal to 5 small square. So if this is equal to 1 centimeter, so this one, and this equals 4 times setting. So it is 1 over 5,000 times 4. Which is equals to the answer of 5 times 10 to the power of minus 5. So that is how you do find the time by setting of the CRO. Okay, so let's do for the next question. The intensity of the sound detected by the microphone is now increased from its initial value of I to the new value of 3I. The frequency of sound is unchanged, so we need to highlight this part. The frequency of the sound is unchanged. It means that the wave with intensity I and 3I will meet at the same point in the horizontal line. So they will meet at this one, at these 4 points. Assume that the amplitude of the trace on the zero screen is proportional to the amplitude of the sound wave. So intensity is proportional to A square. So it means that I is proportional to constant of 1, 2, 3, 4, 5, 5 is equal to 1 centimeter. 1 centimeter square. So what is 3I? This will be proportional to K and A2 square. So let's determine the new amplitude of the 3I wave. 3I per I equal to K A2 square per K1 square. Just cancel all of the variables I and K. Just cancel this out. You got the result of 3 is equal to A2 square, which means that A2 is equal to square root of 3. A2 is equal to 1.7. 1.7. And just seek for the new amplitude, right? So how do we find it? So we know that 1 square of the old wave is equal to 1 over 5. 1 over 5. It is 0.2. Well, amplitude 0.2. So the amplitude is 1.7 divided by 2. Equal to 8.66. Or this one is can be used by 3 square root of 3. 8.66 or 9. So the new amplitude is 1, 2, 3, 4, 5, 6, 7, 8, and 9. 6. This one. So we get this point. And 1, 2, 3, 5, 6, 7, 8. So that's the new amplitude. Just write this down. I'm sorry for the untidiness. And they do meet at the same point of the horizontal line. Well, it's not the same. Okay, so that is how the new wave should be formed. Is D. Okay, so this was mentioned on the figures, right? So explain parent light waves from the slits from an interference pattern on the bright and dark fringe on the screen. Distance between the two adjacent bright fringes is 4 times 10 to the power of minus 3. So this is the central bright fringe where the bright fringe is formed, and explain why a bright fringe is produced by the waves meeting at point P. So if you see from like this is depression, and when light is comes out, it will form line like this, and this. So this is the it was produced at point P because the path difference from both of the slits to P is 0. See, it's 0. It means at the same point. Or you can say that the phase diff between waves at P is 0. So constructive interference occurs at P. So the next question, we need to calculate distance D. So we got the equation. We know the equation that wavelength is equal to X over D, right? And A is the separation of the two slits, and X is just the distance between the fringe, between two fringes. So D is equal to 3.6 times 10 to the power of negative 4 times 4.0 times 10 to the power of negative 3 over wavelength 630. But we need to keep in mind that it was in nanometer, right? So then the answer is should be in meters. So we need to convert it to meters by divide 2 10 to the power of negative 9. The result that the distance is 2.29 meters. 2.3 meters. So that is the final answer of this question. So I think that is all from me, guys. Thank you for listening. I hope you understand. Sorry for my mistakes in explanation. I hope we will get the best result for our S level exams together. Okay, that is all from me. Wassalamualaikum warahmatullahi wabarakatuh.